Thanks, Sid. It's so pleasure to join the Nodes conference, and I finally have an opportunity to share my experience on machine learning with graph with all over the world. Actually, this is my first English presentation, so I'm a little bit nervous, but fine. So my lecture will be 15 minutes, and first I will introduce you my video channel. And then I will introduce you the best lectures about graph machine learning. That's Stanford CS224W. This is very good lectures. So let me introduce my video first. This is my video channel. You can use this link URL to get access to the bilibili.com webpage. And my video channel is about machine learning, deep learning, also convolutional neural networks, computer vision, as well as AIGC. This video is about to use AI to draw pictures in science fiction novels. And I also made lots of videos about AI paper reading in object detection, image classification, as well as image segmentation and machine learning with graphs. And recently, I made a series of lectures about explainability of AI, also called XAI. That's open the black box of a machine learning algorithm and know it, explain it, and trust it. And this videos is about augmented reality. You can use these tutorials to make your own AR gift for your good friend or your company. And this lectures is about AI paper reading about graph. That's deep work and Neo4j, as well as GNN. That's about graph neural networks and graph machine learning. I also make a lot of videos about data mining, data processing, and machine learning basics. So that's my video channel. I have been working on this video channel for 4 years, and I'm now a good uploader in China, and maybe you can watch my videos in the future. And I also make lots of applications and projects using Neo4j. For example, this is a medical question answering application. You can enter your question, and the graph database will give you its answer. This is nodes and attributes. Also relations. Using GDSP, Graph Data Science Playground, you can do lots of data mining about graph. Yeah, and then I would like to show my AI paper reading, and this is my best work, I think. I make tons of notes about many famous paper about artificial intelligence. And this paper, I have been working on these papers. These papers is very famous and have very influential power. And every student in China, or maybe every student in all over the world, will need to read these papers. And I make tons of notes and make videos to read this paper sentence by sentence to let you learn this paper better from the beginner. That's so-called from zero to hero. In graph machine learning, I also make lots of paper reading and notes. For example, this is deep work, represent a node embedding algorithm, a classical node embedding algorithm. And this is Neo4j, also node embedding algorithm. And I would also like to introduce BIAS with you. This is a biomedical information ontology system, and you can query many medical terms such as COVID-19 or some, for example, fever, and you can query many medical papers. It has a lot of knowledge graph about medical. Okay, and then I would like to share CS224W with you. I think this is the most exciting and the best materials about graph machine learning. If you are a beginner, if you are a freshman in graph machine learning, I would like to recommend these courses with you. Let me introduce its schedule. First is machine learning for graphs introduction, and the teacher, this teacher is the author of Neo4j, will introduce the history of graph machine learning and classical methods and advanced methods about graph machine learning. And in lecture 2, traditional methods for machine learning on graphs. He will introduce some classical traditional methods before deep learning. And from lecture 3, it will be node embeddings algorithm such as deep work and Neo4j. In lecture 4 is a famous PageRank. Google used PageRank to build its first search engine, and this is very famous in graph science. From lecture 5, the teacher introduced GNN, graph neural networks, and it also tell us some ideas, some design architecture in graph neural networks, and also applications of graph neural networks. He will introduce such as AlphaFold 2, and use graph neural networks to build your recommend system, to build your drug designer, and use GNN to do some AI for science work. That's very exciting, and also frontiers about artificial intelligence. In lecture 10, from lecture 10, it will be knowledge graph, and this is also a basic topic in graph science. And from lecture 13, it will be some applications about GNN, such as community structure, such as deep generative models. We can use AI to build another new graph. Also, some advanced topics on GNN. This course is totally free, and you can search on YouTube to watch its previous lecture. Also, slides and videos. Also, it offers many Colab homework. You can run directly using Colab. You need to have some Python basics and machine learning basics. I think graph data mining and graph machine learning will be vital importance in the future, as graph data structure will be more and more important, such as in AI for science, medical design, and the social network, social relationships. Also, many papers also have social relationships, has links. And I would like to introduce you another platform. This is a Chinese paper reading platform. Its name is readpaper.com. And you can search paper, make notes of paper, discuss paper, and connect papers. For example, I would like to search deep residual learning for image recognition, also called ResNet. And you can see its connections, its citations, and the papers whose citations is it, the papers who cite it, and its citations. It's also a node link structure, also called graph structure. Just like connectedpapers.com. And the graph structure will be more and more important in the future. And also, graph machine learning will be more and more important in the future. So if you are a beginner, if you are a freshman in college, or if you are a totally freshman in machine learning, and I would like you to learn graph machine learning from the beginning using CS224W, this course. So that's basically my lectures. Sid, do you have some questions? Yeah,
All right.
15 minutes.
Thank you. Thanks, Tommy. It was a great session.
Yeah. Should we have QA session?
Yeah, that's what I'm just checking if we have Q&A in the chat window.
Yeah,
But more or less, your links have been shared with everyone. Let me just broadcast them for everyone.
yeah. And especially in China, we have a very poor fundamentals of graph machine learning tutorials. So these lectures will be very important for Chinese students. And I hope there will be more courses and lectures like this in China.
Definitely, definitely. This is awesome. And I think Jason is asking for the link to Bilibili as well.
Oh, of
Would you mind
course.
sharing it with me or in the chat window directly?
I will send it to you.
Cool. Yes.
Bilibili.com is just like YouTube in China, and many teachers and students, they will share their knowledge, share their experience about learning on Bilibili.com. And that's like a learning website.
Thank you. All right. So happy to be here today. I hope you're all still awake at the end of a long day. I wanted to take 35 minutes to talk about Neo4j and NeoDash. And not just NeoDash, I wanted to take it a bit bigger, the entire topic of visualizing graphs and how it fits within a Neo4j project. So let me dive right in. Right, my name is Niels. I'm working as a consultant at Neo4j, and what that really means is that I do full stack Neo4j development at Neo4j's customers in Europe. So this could be anything from data modeling to API development, visualization, GDS, but visualization is really my favorite topic of all time. That's why I'm here. Right, so my message here today really is that visualization fits within many parts of a Neo4j journey, really starting from the modeling itself to writing queries, to exploration, and eventually dashboarding and making reports for end users. So I'm going to hope that I can fit this in 30 minutes, but the ultimate goal today is to build an interactive rail planner powered by Neo4j. So just to set the stage before I dive into the live demo part, what is graph visualization? So this is my personal definition of visualization. So for me, graph visualization is a method to understand and explore and make decisions on graph data. So this is a pretty broad definition, but it really spans many different aspects. So in my world, visualization is really part of almost every Neo4j project, because in the end, the human beings are going to be the ones working with the graph, and those will want to see a nice visualization. So important here is that graph visualizations are not just the force-directed layout we all love, but it could even be a flow diagram like this Sankey chart, for example. Very different way to look at your graph, but still a graph visualization. And if you have geographic data, so data with coordinates on them, your graph could even be visualized on a map. So to me, that's also a graph visualization. So really multiple different types that together make up this category of visualization tools. But it's not just the type of visualization. It's really also the type of tool that you're using. That's very important. So as I said, a project has many different goals, and different goals require different tools. So to walk you through 4 tools today, I'm going to start with modeling. And a modeling tool that we like to use is arrows.app. So a modeling tool is really just a virtual whiteboard for drawing a graph schema. So you can draw nodes, you can draw edges, you can draw properties on the nodes and relationships. And it's a communication tool. So there's typically no animations, but styling options, adding nodes is very important there. A type of graph visualization, really just like the ones that we're used to seeing. Then moving on, once you have your model in place, you probably want to load your data and you want to run some queries. And the output of these queries will also be graphs, right? So you need a different tool to visualize the result of your ad hoc queries. And that's where analytics comes in. So the Neo4j browser is a great example of this. You can write Cipher quickly. You have small views, but you can iterate quick and you can add some simple styling and run some algorithms. So that's the next visualization tool that comes into play. Then the next step, you got your data loaded, you've got some queries for developers, and you want your analysts to be able to see the data, right? Explore the model. And maybe these people don't know Cipher. So this is where a tool like Bloom can come in and really have a no-code interactive way to see your graph and explore it and walk through it. So again, a different type of tool. These tools like Bloom, they can do bigger graphs. They have nice styling options, custom exploration. Very different purpose from the previous two, but all of them together, they fit into this journey, right? Then the last one, and this is obviously my favorite, is dashboarding tools. So you've got your developers that write queries, your analysts that do exploration, but you also have your business users. And these are the people that they don't necessarily know Neo4j or Cipher or even the data model, right? They just want to make decisions on data. And that's when you give them a very curated dashboard with maybe tables, but also graphs or maps or bar charts. And the key word here is actionable insights. So these are people that want to make decisions on data. And that's where a dashboard comes into play. And NeoDash is a tool to accomplish this. So diving deep into NeoDash. So what is NeoDash? It's a low-code dashboard builder for Neo4j, open source. And this is a project that I started about 2 years ago. And I have currently a lot of people helping. There's support from the community, people inside Neo4j. So it's become a really nice, big project, much larger than what I expected 2 years ago. And it's been seeing quite some interest in the community. People love to use it to prototype dashboards or even bring their dashboards to production. And I'll show you a demo of this in a bit, of course. And this is a tool that sits within Neo4j Labs. So it's not a Neo4j product. It's a community supported kind of incubator tool, just like Neosemantics and some others. So great to use this together with your other tools. So we're talking about rail planning today, right? That's the topic. So I wanted to zoom in on some of the features that NeoDash has for visualizing geographs, so graphs with position data. So we can imagine the traditional view where you have nodes and relationships on a map, where NeoDash is able to map a points property from Neo4j automatically onto a position on a map and visualize that. But it could go even further. You could have country data. You want to see numeric values, for example, on a map per country, so population. And this is called a choropleth map. And this is also something that we have in NeoDash at the moment. Then the third option right now is a heat map. So visualizing data, let's say the frequency of points in a specific location. And heat map is a great way to see that. So a lot of these things were inspired by some of Estelle's work on NeoMap. If you haven't seen it, check it out. Very, very cool tool. and very interesting to integrate that into NeoDash. And this has been also an effort by the team working on NeoDash. So really, really cool work here. So, but yeah, so let's dig in, right? We have all these tools available, and I just want to show you how they come together to fix a real problem. So in this case, building a real planner for the European real network. All right, so I wanted to show you first the data set that I picked. So I was looking for an example of a project where visualization comes in many places. So I found this really cool data set published by Open Data Soft, which is actually it's two tables, one with all the stations in Europe, so the stations with their coordinates, and the other one with the tracks, so the track fragments that are making up this giant network. So we have about 8,000 stations in here and 88,000 tracks, each which consist of segments. So maybe it's best if I just show you the data. So this is the source data, one of them, the network of track segments. And as you can see, every track has a location, but it also has a shape. And when I hover on this, it even shows a little map preview here. So you can see that one track consists of many segments. And these make up kind of a curved line, and the curved line is this track, and the segment is kind of a straight line. And you can see here that we have coordinates for them, which is cool because we can put those in Neo4j. And we have some other information like which country it's in, a couple of codes that mean how it's used. Is it a military track or is it used by commercial trains? Some of them have names as well. So we can all put this into Neo4j together with the stations to build up this real network. Right. So the properties, I just talked to you about them. We have for a station, we have the ID, the name, the coordinates, when it opened, country code, and the usage category. So is it a commercial station or not? Then the tracks, we have ID, name, coordinates, and then this list of segments, right? But also we have the maximum speed that a train is allowed to go. And that's actually really useful because it lets us make an estimate of how long a track would take to ride over, right? So we have the distance of the track and we have the speed, so we can calculate how long is it going to take to go over this track, and that's super important for the routing use case that we're doing. All right, and again, this is quite nice with Neo4j. We have spatial functions which allow us to calculate the length of a track. And then with the max speed property that I just mentioned, we can estimate how long will it take to cross over this track. And then the problem here was, can we come up with a real planner by just looking at the infrastructure? So ignoring train times, ignoring train schedules for now, just looking at the infrastructure itself. And that's where we get into our little journey here. And I wanted to show you how each of the phases in this project is involved with a different tool, a different visualization tool. So we're going to start off with data modeling. And I just wanted to show a little bit of background here on the concepts that I used for building this network. So we have stations. Stations are places where you can get on and get off, obviously. And we have junctions. And junctions are points where two tracks meet. So when a train is going over a track, at some point the track splits, right? It can choose to go in one direction or the other, and that's a junction. And we use this as an entity in the routing network. And then points are the segments, let's say where a segment starts or ends. So in this example kind of sketch on the right, we see that the red dots are points, the yellow dots are stations or junctions, and the lines are segments. And as I said, we have relationships in the graph. A track can consist of several segments, which can be curved, and a single segment is a straight line. And then what we eventually want to do is create route relationships, where a route consists of multiple tracks and ends and starts at a junction or a station. So this will be kind of the ingredients for our planner that we're building, essentially, right? So first thing that I want to show you is the data model. And I'm going to jump over to Arrows, which is a free tool that you can use for modeling Neo4j. And this is technically not a data model; it's more an instance, right? So we can see. I try to draw an instance of what a piece of the network would look like. So I'll just explain this to you quickly. We have station nodes in green, and stations, they have, for example, a track leaving from it to a point, and that point might have another track going to another station. And these two tracks, they make up a route between station 1 and station 2. Now we also have track segments. So this track consists of two small segments that are kind of the curved track. And this is in higher level of abstraction, the distance between a station and a point. And then, as I said, the junction is where multiple tracks come together, and the train can decide to go in direction 1 or direction 2. So this is a really nice tool. And one of the things that I haven't done yet, which I just want to show you quickly, is adding properties. So as I said, on each track and every route and every segment, we have a length, which is, let's say in this case, well, let me pick a better example here, maybe this one here. We have a length of 300 meters. And because we know the maximum speed, we can calculate that this will take travel time, seconds, maybe that will take, let's say 30 seconds. And this is actually what the graph will look like in the end. These properties are stored on the route relationships and on the tracks. So arrows.up is a nice way to get modeling and draw instances and explain the idea to your audience. Right, so we have our model in place, and now we can start loading up the data. So I have created a GitHub repository, which I will share. And this has a bunch of queries in it that load the data. You can run it locally and create this graph for yourself. So I won't show you the entire script right away, because I think it's going to take too much time. But what it essentially does is it clears up your database, creates constraints for you, and loads up two CSV files, so the railroad segments and the stations into the graph. And this script as well takes care of calculating these distances that I talked about, the travel times, and creating these route relationships. It takes approximately 2.5 minutes to create a network that is fully routable. And I will show you in the Neo4j browser how we can use that. So moving on, we have loaded the data. Now we can try running some Scifo queries, right? So I'm going to pick one of these queries and actually go back into full screen and jump to my browser. So I cheated a bit here because I already loaded the data earlier, which means that I can now run some queries. So this query here, and I think I will zoom in a little bit so you can read it. This query here is going to find the shortest path between two stations. So we have a station N and a station M. N is Rotterdam Central Station, and M is Den Bosch, which is a very hard word to pronounce for non-Dutch speakers. But by using our network now, we can use the Dijkstra's algorithm to find the shortest path between the stations. So if I run this, the browser will give me a graph visualization showing me the route between the different stations. So here we start at Rotterdam Central right here. Then we hop over these kind of red nodes, which are the junctions. We cross a couple of other stations and eventually end up in Den Bosch. So this is as you can see, we now have this whole thing available to run such a nice routing. And the fun part here is we can run this both with distances and travel time. So if I tell my algorithm here to use the travel time in seconds to find the best route, I can run this again. And we actually see that it finds a different algorithm. So, I mean, it finds a different route, right? First, we went by 1, 2, 3 stations, and now we only crossed 2 stations. So by estimating travel time, by estimating a route based on travel time, we actually get a different result than using the distance-based measure. So that is a very cool way to see how this makes a difference, and also how the Neo4j browser can be used for visualizing this kind of analytical queries very quickly and prototyping essentially the different things here. So heading back to the slides, and I'm being cautious of time. Moving on, we have our data loaded, we checked that we can do some routing, and now we can try out some Bloom, right? So I'm going to jump into my Bloom instance here. And I just wanted to show you what Bloom looks like. So Bloom is completely no code. You can navigate your graph without writing any cipher. So if I started the station, for example, again, Rotterdam Central Station, you'll see that I'm typing here just natural language, right? And Bloom figured out that I'm talking about this node with this label, which by itself is already pretty nice. And then I can see, okay, how far can I go from Rotterdam? So let's see, if I do, let's see, 1, 2, 3, 4, 5 hops of route relationships, where does that take me? So I can run this, and then Bloom will show me a very nice graph here and says, okay, I started Rotterdam Central. I can cross these junctions and end up in Schiedam or in Delft. And then with Bloom, I can also expand from here and explore, go from Delft to Rijswijk, and I can go from Rijswijk to another junction, and maybe that will take me to some more places. And you can freeform walk through your network with Bloom, which is great because you don't have to know any cipher and you can do some nice exploration here. Now, that's Bloom. And to wrap up this conversation, I just wanted to show you NeoDash. So as I said, NeoDash is a tool for building dashboards. So I'm going to get my, let's see, I'm going to get my query that I had here that did the pathfinding using Dexter's algorithm. And I'm going to put that into NeoDash. So I have NeoDash open here, connected to the database. And I'm going to add a report, which is just a box that has a cipher query in it. So I'm going to take my cipher query from just now and show this as a graph visualization. And then I see pretty much the same thing that I saw inside my browser, Rotterdam Central ending up in Den Bosch. Now, the cool thing about NeoDash is I can take this exact same query and turn this into a map. And because these nodes have geospatial attributes, NeoDash is aware of that and can plot the result on a map. So I'm just going to make this larger so you can see that. And now we see, as we expected, a route that starts in Rotterdam and ends in Den Bosch. So that is pretty neat. But where it gets super interesting is when we make this interactive. So what I can do is I can add another visualization to NeoDash. And for example, I want to see all the stations in the Netherlands. So I can do s.country code 3 is NLD, which is the 3-letter country code for the Netherlands. And then I can return the station name. And maybe I want to see the station type as well. And we can plot that in a table. So now we have a nice table here with different stations in the Netherlands. And where it gets fun is if I turn on my extensions here. So this is a new thing in NeoDash, is something we call extensions. And one of them is called report actions. And these add interactivity into your dashboard. So go toggle this on. And now if I open this query again, I see an extra button that says set report actions. What I can then do is add a trigger. If the user clicks on the station, set parameter NeoDash station name 1 to station. And if I save that, it turns my table into a table with buttons. Now, you'll see where I'm going with this if I make another table. So I'm making the exact same table here. And I'm also adding a action on this one. Same thing if I'm clicking station name. If I'm clicking on the station, I'm going to set station name 2 to station. So now I have two tables that I can click this button on. And now I'm going to parameterize my original query. So here I can plug in NeoDash station name 1. And I can plug in NeoDash station name 2. And what I can do now is choose a station here, choose a station here, and this visualization will automatically be updated to show the route between the stations that I chose. So interactive, an interactive railway planner. It's already kind of here. Now, I just wanted to show you, this is obviously something that I can do in 1 minute, but if I take a bit more time to make a nice dashboard, what that could look like. So I have a prepared dashboard here that I can load. So I click on the load button. I load up my JSON that I created. And now I can see this dashboard that I created earlier, which is the real planner for all stations in Europe. And what I can now do is go from Rotterdam to Berlin, Friedrichstraße. And you see that this updates automatically. Now we have our entire route from Rotterdam to Berlin. It takes approximately 6 hours, this long. This is my average speed, and I'm visiting 19 stations. And the speed here is really what's amazing about Neo4j. We can do routing so quickly with Access algorithm. So we can even go, for example, from Glasgow and see that we're crossing, let's say in this case, 3 different countries. We're also crossing the Eurotunnel here, which is very nice. And 14 hours takes it to one station to the next, crossing over 3,374 segments. And I promise you another view here. So I just wanted to show you the other maps that we can see with NeoDash. So we have a chloroplat map where we have the numeric values for each country. We can see the number of stations per country. When you hover over it with some color coding, we can do grouping. So if I zoom in here, you see that it kind of aggregates the stations into groups. And if I click in it, it will zoom in and show me the individual stations on the map. And then the heat map, I can see the density of stations, right? We see that in Holland, there's a lot happening here. The center of France, not so much. So we can see the density of stations all over Europe. So that is NeoDash. And really what we've seen now is kind of a full journey here from modeling to loading the data, to querying, to exploring, and then dashboarding. And the message that I want you to take home is really that visualization is part of every part of your project, right? So every step of the way, visualization helps you do this more efficiently and helps you communicate to your users. It's really a Swiss Army knife. And the thing is that it's never one tool that does the job. You'll always need multiple to do the trick. And these are some of the tools that you can use. All the data that I made here is available for free. So I made a GitHub repository. You can find the source data and this dashboard as well. You can see the dashboard that I just created in the NeoDash gallery. So the NeoDash gallery is a website where we collect NeoDash dashboard that are made on public data. So if you go to neodash-gallery.graphapp.io, you can see a couple of dashboards. And if you click on load here, you can try out the dashboard without loading anything into Neo4j. It's a public database. That is it for my presentation. I haven't had time to look at the questions. I hope this was interesting. And yeah, looking forward to answer some questions.
It definitely was. It was too fast. That's a negative point. It was
too fast.
Too short. Sorry, too short. So yeah,
I try to fit it into 30 minutes.
Yeah, before we come to some questions, here is the wonderful feedback you got. Yeah. Whoa, so many. I hope you can see this phenomenal example. That's exactly what I needed. Neo4j is an amazing tool. Yeah, there were some questions that got raised. In the meantime, whoa. Yeah, wonderful feedback all the time, all over the feed. I need to scroll now because all the people are clapping. Yeah, so maybe you can answer this. I cannot answer this. But maybe it's even just more interest than Neo4j will specific. Is there a tool to represent geographic data in 3D, considering elevation?
A tool to represent geodata in 3D. With direct Neo4j integration, not that I'm aware of, no. They're probably out there, but not directly integrated with Neo4j, as far as I know, unfortunately.
All right. So maybe another person in the chat has an idea, has anything seen before. So you can pass this on to Philippe. So yeah, there's also a question about sensitive data. So Danubio asks, when dealing with sensitive data, what are the concerns of using NeoDash? I think he refers to that it's hosted somewhere or needs to get hosted somewhere.
Yeah. So the NeoDash that I showed you was inside Neo4j Desktop. There's also a public environment on neodash.graphapp.io, but it's an open source application, which means you can clone the app yourself and host it within your own, let's say, secure system, right? So you can use your own deployment of NeoDash to be safe and make sure that your data stays within your private network. It's possible.
Great. I just need to look over because you've got phenomenal feedback on this. Let me scroll a little bit. I don't think there are any questions. It's all the way positive feedback on your talk. So yeah.
Great. And I see.
So it's open source. You also take pull requests, right?
Yeah, absolutely.
If
so
anybody's interested to support you, which, for example, with an integration of 3D map representation.
Yeah, absolutely. I mean, there you can make, if you have requests, you can make an issue, or you can of course contribute. There was a presentation earlier this morning of some people that forked NeoDash to make a solution for cybersecurity. Which is really nice, and they are also contributing back. So it's really an open source ecosystem here that everyone can contribute to.
Yeah, and yeah, the question. There's no question. Yay. Ahmed asked, you've demoed interactivity at the table level. How far can we go with interactivity on the graph itself? So
yeah, that's a good question. So in terms of interactivity, with these report actions that I showed, you can define click events for nodes as well. So let's say you can add a trigger that if a user clicks on a node, another visualization gets updated, similar to how you would click on a table cell. So in theory, you can set up a click event in one graph to set a parameter, which then updates another graph, and you can create a chain of graphs that are all interactively related with each other. So you can get creative and make a really nice journey here in NeoDash.
So I think you're looking forward to all the examples you get after today, what people create, come up with. That would be good to give feedback to Niels. Yeah. And yeah, I think that's it. Glad you were here.
So welcome everyone. I'm very happy to be here with you today. So a few words about myself before we start. So I have a PhD in particle physics, even if I have not done any physics for something like 8 years from now. But after that research period, I actually started working in industry as data scientist or data engineer, using mainly Python as a programming language. I started actually wandering in the Neo4j community in 2019, where I built the NeoMap application, which is a React.js based application to visualize spatial data stored into Neo4j into a map. I also authored a book about graph analytics with Neo4j, where we have an update coming next year with the new feature of the Graph Data Science Library. So for the past years, I've been working in a startup called Smart Grid, where we are trying to build a digital twin of the world, modeling all the entities and the relationships between them. And since a few months, I'm also working at GraphAware, so nice team with doing a lot of Neo4j. So back to this talk. In this talk, basically, we are going to build this. So we are. This is the way I started thinking about the project, saying, okay, I want the code to look like this, and then I step by step implemented the different features, and that's the path we are going also to follow during this talk. So first, let me give you a bit of context and explain why I had this crazy idea of building A NeoGM, first of all, when I started working at SmartGrid, we started from scratch. And so it was natural for me to use Python, which was the language I was more comfortable with, and is also good for prototyping. So that was easier. And at the same time, we had quite a complex graph model. Well, complex means that we had very unstructured and exploded model. Exploded meaning that to build a given object, I had to do multiple hops into the graph to retrieve all the attributes that were important for me. The reason for that is that we had to track a lot of things like user changes and all of this. And that ended up with very bad query performances, like 2 seconds for a given request that was not manageable even for a prototype. And at the same time, we all know that thanks to Scifo, we can actually perform queries that goes that perform multiple hops and retrieve the data that we are crossing during that path. So the question is, can we take advantage of this Scifo feature in order to reduce the number of queries and improve a little bit the performances of our request? So when you work with Python and Neo4j, you probably have heard about some of these tools like NeoModel or Py2Neo, which both contain an OGM part. Or, for instance, I also crossed another tool that is Python that lets you write Scifo queries, but only using Python. So you have an example in the terminal in this slide, for instance. But Python doesn't have the object mapping part. And from what I could see in NeoModel and Py2Neo, it was not possible to retrieve the thing that was important for me, so to retrieve multiple objects in one single hop. So that's why I basically decided to do and kind of write my own tool. First, because it was a requirement. Second, because it was also important for me to understand how those tools are working. So the requirements were so to be able to define a node with some properties, match a node based on property values. And the last one was the most important, so prefetch some related node on demand. So for instance, when I query a movie, I also want to fetch the actors of that movie in the same query. So in this talk, we are going to go through step by step. The code is already available on GitHub. I confess I will not have time to discuss and explain every single line of code one by one. But you will have the opportunity to watch the code afterwards. So we are going to use the dataset, the movie dataset, the movie graph, which is a well-known graph, using the movie nodes that have a title and the release properties, and the person node with a name, and the two properties that are circled here, so the acted in and directed relationships. So let's get started and go to the code. So here you can see that the only requirements that I have are the Neo4j Python driver, and I'm also using PyTest to write some tests and see that everything is working as expected. So if I start by writing tests, what I want to be able to do is to define, for instance, so here a movie class with a title. Those properties need to be set, and then I want a function that is able to basically create this create statement where I want to create a node with a movie label and set its properties, right? So the easiest part, of course, is to write a movie class with title and release attributes that we can set, and we can build that function here that return the query as we expect it to be. As you can imagine, you will have to repeat the same function for every single node label that you have in your graph. So build, create, person query, and so on. And the same for match, which might be quite complex, quite complex in the end. So my idea is to change a bit this, and while still having the same, actually the same properties, so the same test, we can build a class that this time looks like this. Okay, we have a movie class that inherits from the node class and defines two properties, title and released. So here I do not want to go deep into the details of how it is implemented, but there are two important things to note. First is that the node class and all its inherited classes will be built from a given meta class in Python. And the goal of this class is to analyze what are the attributes of this class. And as you can see here, if the attribute is an instance of a property, it will be saved. And the important thing is that all the nodes subclasses will have an underscore properties attribute that contains a property dictionary with the name of the property and the instance of the property attached to it. So that's one thing. And once you have this, you can imagine it will be easier to build all the Cipher queries we need. The other thing I want to show you is how this property actually works. So there are actually two functions or two methods that are important, which are the set and get function here, which are the function that will be called, for instance, when here you're setting the title property on a movie object, then this is the set method that will be called. So there are a few advantages of using this pattern here. One of them is that you can add properties into the property class, right? So you can, for instance, define here is required and change the behavior of the property if this property is actually a required property. The other thing is that when you set a value here, you can have a behavior that depends on the property. So you can imagine creating different subclasses of a property, like an integer property or a date property, and you can validate the value that is passed to it and raise exception if it does not match the value you're expecting to see. Okay, so if we check here our tests, you see that I have now a build create query that is a method of the node class. And this method will actually use our underscore properties dictionary that in order to build the set statement. So the last part of the query here. And that's basically it for this part. We can also do something that was not possible before, which is we can raise an exception if we are passing an unknown property. So if we are trying to build a movie with a property that is not declared in the class, we can decide that this won't be stored into Neo4j and to raise an exception if we try to create such an object. So let's go ahead, and now we are able to build the create statement, and let's see how we can actually do the same for the match statement. So here I have the exact same test as before, and I'm just adding some tests to actually build this match query. And this actually is very similar to what we have done before. We are building the match statement in this class. So this is the main difference compared to what you have seen before, that instead of building all the Cipher query into the node class, I have extracted that part, all the parts of the code that build the Cipher query into a node manager. And this manager is actually attached as an attribute to all the node class here. So it's called Q for query. And what it changes is that now, in order to access all the create and match query, we will have to use movie.q.create query or .match query. So that's just a matter of organizing the code at that stage. And we can see, so here I just repeated create queries, and we also have the match query that we'll use. Here you see that it uses the class name, the class name as label. And we have the where statement that is built in the same way using the filters that are passed to it that are joined with only an AND operator. And we are returning the node. So in the end, the match statement looks exactly like this. And actually, we can test. I haven't shown you so far, but all the tests here are actually passing, right? And the same for the match query. If we are trying to match a node from a non-existing property, then we will have some errors raised. So one thing I want to show you here and is that, so instead of returning directly the node here as we're doing, we can change a little bit that query and take advantage of Scifo map projection to return directly only the properties that we are interested in as a JSON object. So let me share one sec the Neo4j browser, and we'll see. Here we go. So Scifo map projection are actually very convenient, especially when you're trying to build this kind of OGM here. Oops, where is my code? So here it is. Up. And what we are doing usually is that we are doing this, and you see that the object returned is a complex object with all the information about the node. And when you use the Python driver, it returns an object of type node. What we can do instead is using map projection, for instance, like this. And you see that here the object returned only contains, is basically a JSON containing only the properties that we can also configure and to return, for instance, only the title. And we can also add some computed properties like the node ID in that way. Okay, we are returning only the properties we are interested in. So let me just show you why this is interesting. I'm just taking a bit of advance compared to what I want to show you. The very important thing, and that we will definitely use in the following, is this ability here to, in the map projection, to follow some relationships. So here I'm starting from a movie. I want to return this movie title. And in the JSON I'm building, I will add an actor's key. And the actors will be built from this pattern here. So from the movie node, I will follow the relationship acted in until all the persons that match that pattern. And for each person, I will actually extract the name property. So if I execute that query, you can see that I have a JSON with the movie title, my actor's key, and the actors contain a list of nested JSON with a name. And what is even more interesting is that this pattern that we are building here can be nested. So I can follow again the relationship from the actor's person to, for instance, the movies that that person directed. Okay, this is what is done here. I'm extending the initial query, which is still the same. And for each person acted in a given movie, I follow again the relationship towards the movie that this person directed. And here I obtain another nested JSON, still with the Cloud Atlas movie, all the person that acted in that movie. And you can see that, for instance, in our graph, we have the information that Tom Hanks, who acted in the movie Cloud Atlas, also directed another movie. So we can follow relationship in that way. So let me go back to the code. Sorry for the time to switch window. Yeah, so here we are. Now, so we have our node definition. We have our match and create statement that are working based on the node definition about itself. Now we are going to implement the properties. Okay, so now we are actually using another test. So here still I'm fetching my movie. And now what I want is that when I access the actors, doing movie.actors, I want actually to retrieve all the actors of the movie. And if I access the actor's name, I want them to be actually implemented. So let's see how this is done. So I've actually added, compared to the code before, one person node with a name property. And in my movie class, I've added this relationship property that has a few information, so the relationship type and the target node label. So both of these information are required in our object graph mapper. You know that in Scifo, you can build a pattern without specifying, well, either the relationship type or the target node label. But for us, this target node label will be important in order for our code to know which object needs to be instantiated when we are actually calling the .actors. So here, each of the objects in that list should be an instance of a person. That's why this information is required in our case, which is not necessarily the case in Neo4j. So let's see how we implemented this relationship property. So a relationship property inherits from property, so it has the same structure. It has those parameters here, so a type, a target node label, and an optional direction if we want to enforce the relationship direction. And when we are trying to actually get the relationship, which is what we do when we call this famous movie.actors, it first checks if the property already exists, is already cached, in which case it will just return it. And if not, it will fetch the data. And the fetch method is implemented here. So we are basically building the pattern, right, from a start node, the relationship pattern that we are building from the relationship type, and eventually, or maybe the direction that decides on the direction of the arrow, as you know in Scifo. And then we are building the target node pattern, which is the famous bracket node and node label. And we are returning the target nodes and with all their information and their ID. And once we have this, we are actually, for each result, for each node in the target node class, we are actually iterating the node. So that's one thing I've not told you before, but actually the node itself is responsible for creating and instantiating instances of itself. So this is not required. And you can see that we are iterating the node here from the data coming from Neo4j, and it returns an instance of itself. So that's what we are doing here. We have the target node class. We create an instance of this class for each row in the result set, and we are returning those 2 rows. So if we actually run this, we can also test that it's working as expected, and that's fine. The problem here that we have is that, as you can see here, so I'm using a special transaction object that is able to track the number of queries that have been performed during that transaction. And you see that we have actually 2 queries performed, one for the matching the node, and another one, the one we have just seen, to fetch the actors related to this node. This is actually what I want to avoid. So in the next part, what I'm doing is actually I have almost the same code here, but I want to be able to only perform one query. So I want here my query to return only one, my number of queries to be 1. So if I run this, we'll see that actually this test is failing. We will see what are the changes that we need to make in order to make it work. So first, we want to specify what are the fields that we want to return in this in the match statement. So I added this parameter here in the match clause that says, okay, I want to return the title for the movies, and I also want to return all the actors. We are actually propagating this return fields to the function that build the match query here. And in the match query, we are passing this parameter to the part of the query that builds the return statement here. So here again, the code started to become quite complex. So I've extracted the code into another object that is just meant to build the return statement. There are actually 2 reasons for that. One is that the code is a bit cleaner, a bit more organized, at least. And the other reason is that, as you have seen before, we can iteratively build the map projection pattern, adding deeper and deeper relationship. And so we will have an object that is actually calling itself with another set of parameters. And so it's much easier to have a different object. So for now, what this object is doing is that exactly as before, it's returning only the node and its properties. There is no relationship extracted from there. But we are actually going to use this code here. Where we are building the query parts here. So this code is a bit more complex and probably can be maybe simplified again. But the important thing is that it will iterate over all the fields that we are providing. So the fields we want to fetch together with our starting node. And depending on whether the field belongs to the model properties or to the model relationships, then we will append a different part to our query. So if it's just a field, a property, we can append just the field name like this. If it's a relationship, then we will have to build the pattern and to extract all the information from the target node. So what happens if we run this? Okay, if we run this, it's actually failing again. And I know why it's failing. The reason for that actually lies in our iterate function here. So if you remember, okay, I know I've only shown it quickly, but it's actually using only the properties. It's not taking advantage or reading in any way the relationships of our class, and that's what we are going to fix right now. So now my headWrite method is also reading the relationship parameters and adding them to the node data before creating an instance of that node. And we also need, in the same way, to update the initializer class here. And this time, we are working fine. Okay, we have one warning, but all my tests are passing, meaning that this time I have managed to actually fetch the movie and its actors in only one query, because when I actually use that line here, movie.actors, the actors are already fetched, already filled, and I can use the cache results. So that's it for the code. So we can go back to our slides. And yeah, so when we have this, so you can imagine we can extend this code even more, doing some multiple hoops. So that's, for instance, what you can see on the code block on the upper right corner, where we are using this double underscore notation to fetch the actors underscore directed, for instance. So that requires to parse this and build our relationship pattern iteratively, but we have almost everything we need in here. And you can imagine that starting from there, you can also build a more complex match. For instance, building also a relationship pattern and filter on the related object. For instance, if you want to fetch a movie whose actor was born before, I don't know, 1960 or something like this, we can add the ability to filter on operators to build more complex where clauses, adding or, for instance, or clauses, and all of this. And also very important is that once you know what your classes are made of, you know your nodes, you know the properties and the type of properties, whether they are required or not, you can dynamically and automatically maybe build a GraphQL schema that corresponds to that to your node code, to your code. So this is an exercise I did, but the code is way too messy to be shared at the moment. Maybe one day it will. So that's it for this talk. So I put here some links. So first is a cipher map projection blog post I wrote explaining how this works. Again, this is the code for the code that you have quickly sometimes seen today that you can go through and run it. And finally, so the code I've shown today is actually extracted from a bigger project. I'm actually working on to try and clean it and make it public. So it will be public at some point in this repository, but if you check it for now, it will be empty. So last but not least, I just want to tell you a bit about some talks that my colleagues at Graphover are giving at this conference. So the first one are already done, but you can still wait for the recording. And I can only encourage you to listen to Federica and Alessia on one side and Fabio on the other side this afternoon. They are describing super interesting use cases of graphs and Neo4j. So that's it for me. So I think we may have time for some questions. In any case, if you want to reach out to me, you can still find me on Twitter. Thank you.
Thanks a lot, Estelle. That was great. I love this presentation. Yeah, I'm just scanning if there were any questions. So, like, without any specific order. I tried to show. People clap too much. How can we help, for example, if you take contributions?
Well, good. I mean, I think it will I will try to make this public for sure, and then there will for sure be some tests to be done. I mean, if you're interested and you want to contribute and add stuff, you will be more than welcome. Then at some point, I mean, we already have stuff for Python written, so I'm not sure it's worth creating yet another object graph mapper. It will be maybe more clever, maybe, to try and add and see. The reasons why I started this are mainly the ability to prefetch some objects and see whether we can add these features to existing tools such as NeoModel, for instance. That could be maybe more clever than creating yet another tool. That's to be discussed for sure.
All right, thanks. Just a second. Open source at yeah. So you get a lot of claps
Thank you.
for your talk. Just to give you direct feedback on this. Yeah, it was perfect. Thanks a lot. Yeah, and I hope you stay around in Hopin so you can answer follow-up questions. Right now, there's nothing. Nothing
Sure.
more. So yeah, I hope you will have fun with the conference again. And stay tuned for our next talks.